love these summer classes. We go so fast, and we go through, at least we had more than 4 or 5 weeks to do this graduate class. But this last unit of work is certainly involves several chapters. And I'm going to try really hard not to bore you with an extremely lengthy lecture. Again, my thinking is that you will read the material, and there's a possibility I'm going to put some other readings up, but I'm really going through them carefully because I don't want to overwhelm you. You've already got plenty of reading. But if I find something that's particularly insightful and more current, I might post it. But the bottom line, I think for the purposes of our class, we are training managers. We are talking to managers, to MBA students, about information technology and how the department, in this section at least, how does the IT department run, or how does IT get distributed throughout the organization? How do major decisions about IT get made? And so these chapters do kind of dovetail together somewhat. But again, our concern here is that as a manager, you be very much aware of some of the decisions that you will be likely a part of, that you be aware of the importance of understanding enough about information systems and information technologies to be a part of these decisions, and the importance of these. This first chapter talks about architecture and infrastructure, and this is a topic that gets very technical very quickly. And even me, having taught in this area for 20-something years, and a PhD in the field, if you will, and been involved, as I say, for 20 plus years, there's so much about architecture, certainly about infrastructures, very specific and detailed infrastructures, that I just am not that familiar with. There's so much technology out there, it's impossible to know every little thing about all of them. That's why it's important to have people in your organization that can inform you. Again, it's kind of like, the president who has people advising him on foreign policy or economics and other issues. It is not okay for the president to be completely ignorant of these issues. But by the same token, it's pretty well understood that the president is not going to be quite as well, I can't, see, this is why I can't be a weather girl. I can't look in the screen. I couldn't point to the right county or the right weather pattern. It's backwards. I was going to push my hair out of my eyes. I pushed it the wrong way. I'll just let it be in my eyes, okay? Excuse me for that. The president must understand enough about what's going on with foreign policy to be a part of these decisions. I mean, he is the commander-in-chief, so he ultimately has the much authority and accountability, fortunately. But there are people out there that he must recognize knows more, people whose job is to just be aware of and keep up with all of the new and the nuances and the things that are changing daily. And so this is kind of the way we look at managers with respect to infrastructure especially. There are new technologies coming on board constantly. Is the CEO, should the CEO or the marketing manager or the manufacturing chief, should these people understand all of these technologies? Well, it's just not feasible. So if we pretend that that's the way we want it done and we push it all off on that one person or those few people, then we're going to find some real gaps, and we're going to find some things that don't get covered. It's very common to have people in the organization, for example, that are doing nothing but dealing with emerging technologies, for example. So what I'm trying to say here is you've got to have, it's like the Three Bears, the soup that was too hot and too cold and just right. If you spend too much time as a manager drilling down on all of these details, then perhaps you might overextend yourself and create many problems. But by the same token, if you push it all back and abdicate huge portions of it, then you may find yourself in a completely different kind of negative dilemma. What we're after here is just right. You've got to understand a little bit about the technology, enough about the technology that you can understand how it impacts your strategies, your goals, how it helps or constrains that which you need to do. And that's our big idea here that we have with architecture. Architecture is that grand plan, and infrastructure is that more detailed, the translation of or the implementation of that grand plan. It's very, very common to use a home building example when we talk about these issues because they are so appropriate and because we all understand them. We understand having a big blueprint. You know, right up front, the architect has to know, are we building a single home unit or a multiple home unit or an industrial warehouse? I mean, what do you need out of this property I'm going to build? But even when we find that we're building a single family unit, those units are very different for different families. Some people have families with large numbers of children. Some people have no children and no intention to have children. Some people are young and still having their children at home. And other people are older and they've already sent their children out into the world. And so how much sleeping space do we need? How much play space do we need for little guys and little girls? Do we have a pet and we want to have a lot of room in the backyard for a pet to run? And how many bathrooms do we need? You know, and now, should I say desire? I grew up in a home with just one brother, and we made it with one bathroom, but I would hate to have to do that today. And I hear horror stories from friends that had 3 or 4 siblings and how they would line up and fight in the morning getting ready for school. So how many bathrooms do we need? How many sleeping rooms do we need? Our kitchen space, are we big cooks? Do we want to have commercial sized appliances in there, or at least larger and more sophisticated appliances? Or do we need just kind of a little efficiency type? What exactly do we need to accomplish in this home that the architect is building? Excuse me, but I've got a little bit of a scratchy throat today, so I'm keeping myself moist. And if we don't understand all of those things, we could very easily build a foundation that is too small to accommodate that number of bathrooms or that number of bedrooms. We could start to build that on a property that would not allow that large of a space be occupied, or that would have perhaps drainage issues or other things. There's a lot that goes into the actual architecture. You know, do you have a sewer system? If you don't have a sewer system and you're going to have a filled bed and a septic tank situation, does your ground perk? Some of you don't even know what I'm talking about. I live in an area where the ground does not perk well, and so it's a little more frustrating to build a filled bed and a septic tank system. It has to do with how the ground absorbs the moisture and so forth. All of these are architectural issues, and the important thing is that they, when put together appropriately, they allow you to have a home that meets your needs. Put together inappropriately, they will constrain. And you may find yourself being told, oops, we cannot put a bedroom there because of, or we didn't put the plumbing in that part, so that'll be a major deal to move a bathroom into there. Or, where does the heat and air need to go, and all of these things. These are architectural issues. Well, likewise, an organization, when we're looking at the IT, the information technology and the information systems that we will be using in the organization, we need to think about what the needs are going to be. We need to have a network that will support the traffic of our customers. Excuse me. We need to be able to add on equipment when we want to add it on. There's been a boat floating around out in San Francisco for a while, and a few months ago you might have heard people talk about what is this weird thing floating out there off the shore of San Francisco. And a lot of people have traced it back to Google, and they say, well, it's whatever it is, Google owns it. And a lot of people think that it is data. It's just data servers. It's a data center floating out there. Why would it be out there? Well, can you imagine the cooling and the water? You know, you're in the water. Can you imagine how that might be helpful? Of course, if you think about what property cost in San Francisco, that's a pretty big deal too. But again, think about the needs. We think about people locating facilities in various places, and sometimes we wonder, why would they put them in the mountains? You know, a perfect example, Coors Beer. I've been to their brewery, and they're located there in Colorado up in the mountains, and that mountain stream water is a very critical part of their product. So their location is very much a part of their infrastructure. All of that is very important. So this is what I want you to understand. And in your organization, depending upon what your role is going to be in management, but how do the does the information technology architecture and ultimately the infrastructure, how does this either promote or constrain that which you need to do? And if people are completely unaware of potential needs that you're going to have, if the builder looks at me and says, well, we've got one child and I'm going to build you a perfect home, and then they don't realize that we intend to adopt 10 more, and then the home is not going to meet. It's not going to be large enough, and it's not going to have it's not going to have the plumbing and the infrastructure. I've been down at the lake a few days resting my weary leg that I had surgery on, and I was doing a little too much at home, and I was told to get off and elevate and ice for a week. So I retreated to the lake and to our camper and kind of laid around and studied and graded papers and so forth. And but we didn't have access there to the internet, and I would have to leave the campsite regularly to be able to check my email or to communicate, to make sure you all were not trying to get in touch with me, to make sure I hadn't missed phone calls. And if I wanted to post anything on the internet, I had to go somewhere else to do it. And I'm doing 2 online classes right now. So the other class, I've got you on alternating weeks, but the other class I had to post a great deal last week. And so I had to go off site to do that because the infrastructure and the architecture there simply was not, and that was okay for a week of rest and a little bit of, but if that were, if that was my daily work and going to be all the time, it would have been way too troublesome. So this is the mindset that I want you to have going into chapter 6. When you read chapter 6, it makes sense. I think it's going to be pretty understandable for you. But what the chapter is doing is to try to help you understand. And on page 169, in the middle of the page there, near the bottom, under the manager's row, it says, like the homeowner, the manager must understand what to expect from IT architecture and infrastructure to be able to make full and realistic use of them. The manager must effectively communicate his or her business vision to the IT architects and implementers, and if necessary, modify the plans if IT cannot realistically create or support them. Without the involvement of the manager, IT architects could inadvertently make decisions that limit the manager's business options in the future. This kind of summarizes what I've been saying to you, and this is the, the argument, if you will, for this chapter. And so when you are at the firm and you're hearing these infrastructure or architectural discussions take place, don't hide behind that poster that says, I don't know what they're talking about, or I don't understand. Sometimes if you do nothing more than go to the computer and Google the word, client server, Google it. What is it? Oh, okay. Just that alone will sometimes get you back in the conversation. But it is very critical that you are communicating your needs and that they're well understood. But it's also very critical that you understand the competence. You understand what this infrastructure can offer, or this architecture, and ultimately this infrastructure, so that you can also leverage this, and that you will, as you manage, you will use. And you will take the opportunity because you will recognize and you will understand what the technology can do for you. So this is kind of, in one way, it's just another way of making that argument that we make right at the beginning that says the manager has to be able to at least be a part of high-level information technology and information systems decisions. Now, when we think about, if you look back, look on page 174, they're going to share with you, basically we're talking about the what, who, and the where. We're talking about, hardware, software, network, and data. But, and it's a good framework here that lets you see the difference between architecture and infrastructure. The infrastructure is just the more specific and detailed implementation. The architect draws this big blueprint, and the blueprint shows the basic. But then the actual infrastructure, I go and choose the very toilet I want. I choose the faucets that I want. And, so it's actually putting all of this into place. And so there are decisions to be made, obviously, at both levels. Your book talks to you about decentralized and centralized. And then, and this is the arrangement, if you will. And there was a time when our computer technology was very centralized in the mainframe era. Everything was one, we had one huge mainframe, and it was pretty well, it was very daunting to managers at that point. Things were very centralized. All of the decisions, all of the processing, everything was very much right there at that one point. And then there was an article that I oftentimes have my graduate students to read it, but I'm not going to do that to you, I think, because of your reading load and the shorter summer. But it's an article that was written literally back in the 50s, or late 50s, I think, or early 60s, by Levin and Whistler. And they were talking about how organizations had been forced to decentralize. If you realize, after the war, we had all these, all this prosperity and all of these huge conglomerate organizations surfaced, and people they were very diversified. You may own things that have nothing to do with, you just own all of these different things. And so the bottom line is, it became impossible for one person, just because of span of control. We just could not have centralized control, and especially if things were very different, because the way you needed to behave in one industry versus another industry, and you may have holdings in multiple industries. So because of the sheer size and the diversification and all of these things, it was just not possible, and people were being forced to decentralize and run each of these units a little more autonomously. Now, because they were pushed into that was viewed as kind of a negative thing, because historically people had been very centralized in their governance, and it was kind of a negative attitude, because you were, it wasn't your choice to decentralize, you kind of had to. Well, Levin and Whistler wrote an article, and they talked about information or communication technologies that would be coming down the road, and it was quite insightful given the time. But they said that this technology or these technologies would allow organizations to re-centralize. And they were correct. it did. We do have the potential now. I can sit in New York City and I can control decisions from, in Hong Kong, because I have the technology to not only have the information to do that, but the communication capabilities and so forth. So if I want to be 100% centralized, I can. What Levin and Whistler probably missed was the idea that we might benefit from decentralization and we might choose to stay decentralized. So this is just some food for thought, and this understanding, if you look on page 175, it'll talk to you about the centralized and the decentralized, and then it talks about service-oriented. And basically this centralized was, of course, we can look at a continuum, but the centralized we had when we had the mainframe environment. And then, this kind of dovetails in with the chapter on governance, which is, just a chapter or so over, maybe even the next chapter. But at any rate, we're going to talk about that too. But governance is about the decision rights. Well, if your structure is centralized, then your governance needs to, of course, dovetail with and work together with your physical structure. Where are the components physically located? Well, the physical arrangement will have a major impact on the governance that needs to be in place for this particular. So these two have to match. But in this chapter, when we say centralized and decentralized, we're mainly talking about where the equipment is, and not so much about who's making the decisions, but about physically who's using it, where are they using it, and these kinds of things. But we can think about the mainframe era, and then we had the mini computers, which were a little less centralized. But in the 80s, the PCs came along, and we were able to ultimately have a computer on every desk. Now again, that evolved over time, but that was a much more decentralized. So we began to bring computing power out into the organization. And this ultimately led, that along with the all that's gone on with technology, led to the development of these local area networks and, of course now what we call client-server technology. Quite frankly, I left school in early 90. And at that time, we were still in the PC. The mainframe era had given way to, now we had the opportunity for PCs, and we were writing a lot of work about how do we manage all of these PCs out in the organization, because historically we had a very centralized structure and governance, and all of the power, the computing power was in one place. And now all of a sudden, the computing power has been spread across, the organization, and Jennifer can be out here creating her own spreadsheet, and nobody's controlling that. And oh my gosh, is this scary or what? And so we began to write about things called information centers and ways that we could get a handle on or get a grip on this. On this strange new phenomenon of information technology being out across the organization and being in the hands of people who were, God forbid, not information technology people. And software and hardware was becoming more user-friendly, and so we were coming up with at that time you still needed to be pretty computer literate, but you still had users. We had a lot to say about end user development, because for the first time we had development coming out of the IT group, and we had end users that would actually develop their own little applications. Again, God forbid. And we had to manage all of this, and we had to make it all work in the organization. So I want you to see that picture as we began to decentralize, because we could. And then along came the networking capability, and the internet has really, but we did develop LANs, local area networks. Now with the internet platform and technology, the sky is the limit. But we began to network, and we began to talk about this client-server platform and client-server architecture, where instead of all of the processing being held at a mainframe location, we had clients on each desk or on many desks. These clients were no longer the dumb terminals, and that's an ugly word, but that's what we called them. With the mainframe, you had a dumb terminal, which was nothing more than a screen and a keyboard that you could use for input and output, if you will, but you didn't have any processing. But now these PCs on every desk were not dumb terminals. They were intelligent machines that were capable of doing processing. So why then do we not share the processing between all of our facilities? And so you have many arrangements. When we say client server, and mainframes are not dead, people still have mainframes, but we do have some distribution. It's very uncommon to have it would be very uncommon to have an organization that would look like that old organization with the centralized and dumb terminals. We have client server technologies where the decision is how much processing happens at the client and what happens at a or the server, or a server, because there are multiple servers. But this is what we mean by client server. The client makes a request of the server. The client may do its own processing, but if it's interacting with the server, the client is making a request and the server is doing the processing and sending the results, or processing it back to the client. And we have to have separate hardware written for both the client and the server because they're doing different things. But it's important that you understand what is a mainframe environment. What is a client server environment? What do we mean by it? And it's important that you understand that a client server is not one particular arrangement. It may be one server. It may be dozens and dozens of servers. There may be big mainframes involved. There may be no mainframes involved. It depends on your organization. We might have thick clients where a whole lot of the processing happens at the client and only maybe the data is out on the server. Or we may have thin clients where the client is more of an interface and a whole lot of the processing goes back to a server. So again, these are business and IT decisions that get made with the help of the business and based upon the needs of the business. There's just no way that an architect could go out and build a house. If you just walked up and said, I want a house, build me one, and he never asked any questions, or she never said how many people are going to live there, and do you want to take baths, and do you want to be able to cook, and never asked you one question, just went and built a house. Well, you know how foolish that would be. And would you really allow someone to build a house for you without talking about it? Spend your money? Well, of course not. Well, that's kind of the same with information technology. Build me an architecture, build me an infrastructure and an architecture. Put some computers in my business. My business needs some computers. How many? Where? Who's in charge? What are you going to do with them? It's the same thing when you go to buy. You go to buy a phone or you go to buy a computer. They're going to ask you, what are you going to do with it? Some people play games, and so they need faster processing and they need certain display potential and so forth. Other people do just, word processing and internet and maybe a spreadsheet every now and then. They may not need exactly the same. It depends on what you're going to do with your device. And so, of course, the IT architects have to know exactly what we're going to do. And then between the business and IT, IT is the expert, but you're going to have to make IT understand what you want. Like the plumber, I need this, I need a bathroom, I need, a large shower, I need to be able to do this, I need a handicap accessible shower or whatever. You're going to have to make them understand what you're going to do with the space and what is necessary. Then the plumber can look at you. We had a plumber, we'd just been redoing a bathroom, and the plumber came in and we said, okay, here's what we're going to do. And we had the floor, here's the current plumbing. Here's what we're going to do. And so he made a list and said, these are the supplies you need. I'm going to run this here. We didn't know if he would choose to cut this one off here and put a new one, or just extend this one there, because we weren't experts. No, I can't extend that because that would create a drain problem, or that would create an odor issue, or no, there will have to be a completely new drain here, or hey, we can use that same drain, it'll be fine. You know, we were not experts in the technology of plumbing. So we knew that we're going to have a bathtub right there, so we know there's got to get water in it, and it's got to drain. I know that, but I didn't know how to lay that architecture, or how to make that grand plan, or what infrastructural pieces I needed to deal with. Makes sense, doesn't it? So the other architecture, common architecture that is mentioned here is service-oriented. And now, because of the internet, we are acquiring our software and our data or we at least have the potential to acquire and to manage our data differently. One example is cloud. A lot of us are storing things in the cloud. Rather than having our own storage, we can just store on somebody else's server. And it gives us much more flexibility, and instead of having to run out and buy a new hard drive or a new server rack or something, or hard drives and so forth, we can just send our stuff to another location. We call it cloud because when we are drawing a picture and a diagram to show the data flow, we draw a picture of the computer, but if we're sending something to the internet, we draw a picture of the cloud. So that's why we call it cloud computing, but it's certainly not up there in the cloud. We understand that. But so if we think in terms of using someone else for storage and going out and getting the storage that we need as we need it. Also remember the time when we bought software and we brought it home on God forbid, floppies years ago. But we brought it home on a CD. Now when you want software, you typically go online and you get it, you download it right to your machine. You're getting software off the cloud, if you will. Well, if we can do that, do I even need to go out and get all of Office? You know what I never use? You might say, I never use Access. I never even use Word. All I ever use is Excel. And even then, in my business, all I do is use a few financial functions. Why don't we just go and get the financial functions? We can. So this is the idea they're talking about, software as a service. We can actually go out into the cloud to get a full architecture now, if that's what we want to do. We can go out into the cloud to get a lot of our infrastructures. We can share other units, just like you share a printer at home. So this idea, the sky is the limit, and we're really seeing this evolve. We get more and more. All of us probably kind of get the idea of the storage in the cloud. But what you may not realize is that we can get software, and that this is what we're talking about when we're talking about software as a service. So hopefully this chapter gives you, helps you understand these issues and helps you be more aware of the need, and helps you understand that you've got to articulate your needs and your visions and what you expect to do with your unit or your organization. This is why we see, again, information to you understand. It would be foolish for me to just look at a carpenter and say, build me a house, and look at the plumber and say, put me in some plumbing, and they both are just doing their own thing. Well, when they're finished, the plumber may have the toilet drain in a bedroom because he didn't look at the blueprints and he had no idea. Of course, we have to have this plan. And so you have to be a part of that plan. If you have further questions about this information, obviously, I need you to contact me. Now, Chapter 7 talks a little bit about the business of IT, and basically what Chapter 7 is trying to get across is, what does IT do? And basically we're talking about supply and demand. if the IT supply way exceeds the demand, then we're overspending on IT. But if there is demand for IT capability that's not there, well, then again, we have a mismatch. And then, we are constraining what the organization needs to do. This chapter is talking a lot, and it talks about these 14 core activities. We can expect information technology because, sometimes we don't really fully understand what exactly is it that the IT people do. And am I expecting them to do things that maybe I shouldn't be or whatever? On page 201, we see one activity there, the development and the maintenance of systems. Well, that one's one that we all pretty well get, that we understand that IT does this. Read about that and see. This maturity level here, by the way, is about how mature the organization is with respect to its use of technology. In all organizations, at the very basic level, they have to maintain and develop the systems. Supplier relationships have to be managed associated with developing these systems. Managing the data, the information, and the knowledge. And we've just talked in our last unit about data and information and knowledge and getting those things and organizing them in a way that is useful and disseminating them and sharing them and ultimately using them for business decision making and so forth. And then, of course, it manages the internet, the networking, and all of these things. The human resources as it pertains to hiring the IT people and training them and so forth. The data center, and then, of course, just general support and providing for discontinuities. If we have a flood or a fire or a disaster recovery. On a higher level of maturity, we find information technology actually working with business processes, and we've been talking about BPR. And then, of course, establishing architecture platforms and standards, promoting enterprise security, anticipating new technologies. And you see on the very basic level, some organizations don't do so much with they're not that mature with respect to their IT. Participating in setting and implementing strategic goals. This is where we're beginning to see a high maturity level, an organization that really has that balanced triangle. You would be surprised at the organizations where the strategy and the goals are not really set with much consideration toward the IT people. And then the integration and the use of social IT, which is really coming along. You're told here what IT does and what it doesn't do, and this chapter is just pretty general. And quite frankly, I considered leaving it out, but then I found there were a couple of topics that I wanted to bring forth, so I left it in. Building a business case. This is something that is very important. A lot of people don't understand how systems get developed. Where do they come from? Well, at some point, either a problem or an opportunity is recognized. An opportunity is often recognized by a steering committee, a group more at the top that kind of sees what's going on globally and says, we could be doing this. A problem oftentimes even comes from a user that says, I'm not getting the data to make this decision in the time that I have to make the decision, or my so-and-so is not working properly. But we see a specific problem, and we report to IT that this is a problem and it needs to be fixed. So most systems or applications result as or come to be the actual first mention or the ask is about a problem or an opportunity or sometimes a directive. And a directive comes from people with authority to direct that says you will do this. Y2K was a directive. We had no choice but to fix the Y2K problem. HIPAA that says you will secure data in this way, and you will make this information available and this information secure, and SOX, Sarbanes-Oxley, that says some similar things. These are directives. So directives may come from a boss, or they may come from an agency that has the authority to direct. But at some point, you know, this is raised, and then the people who are, and then a business case is made. And this is, it's not just a matter of saying this is how much it will cost, but more importantly, this is how much it will benefit or it will save. Fixing this dripping faucet will cost $2,000, and it will save us 3 cents a day. I don't know. How long, you know, let's look at this whole thing. Payback. In other words, some things that are broken, we decide not to fix. They're not broken enough. The benefits are not going to outweigh the cost. Or what happens is we have way too many in the pipeline, way too many requests, and all of them do not get funded. Some of them get funded and get pushed down, and then other things come up. I mean, there's always this huge backlog with IT, and most people don't understand that. And you may be in line for a while before yours surfaces and gets funded. But how do they get funded? Because we have a business case that talks about the benefits and the costs. And we're talking about the total cost of ownership, TCO, not just it'll cost this to buy it, but if we have routine and ongoing over the years salary cost or licensing fees or maintenance issues, then we consider that as well. Because we might just look at the cost to actually acquire the hardware and software and train the people initially. It may not be much, but this may be a system that's going to require much maintenance-wise, and so we would need to take that into consideration. So that's why we talk about total cost of ownership. Talks about managing your portfolio. Some of what we are developing are transactional systems, payroll systems, inventory systems, capturing sales, and things of this sort. Some of our things that our IT projects are infrastructural based. They're about developing networks or databases and things of that sort. Some of them are informational systems, like reporting systems and decision support systems and things of that sort. Some of them are strategic systems. So there is a drawing or a figure on page 214 that shows us that in the average company, you've got more money being spent on infrastructure, and then you've got transactional coming in second, with informational and strategic coming in the next two places. Over on page 215, they're reminding you that if you're an organization and your IT is primarily support and it's all about cost focus, you're probably going to have more transactionals, a little higher use of automation. So you're going to have more transactionals going on, and maybe a little less money being spent on infrastructure because you're just supporting and trying to keep the costs down. And but if you're interested in an agility focus, you're going to have a lot more money spent on infrastructure so that you've got things in place so that you can make adjustments quickly. So again, the important thing here is not that you memorize any particular facts or figures. It's just that you understand in a conceptual way that we have these different types. And in terms of what are we developing at the moment, you want that portfolio of what you're developing to reflect what, of course, is a match for your organization. And then I do want to say something about valuing IT, because it's a big managerial issue. How do we value our IT? How do we pay back? How do we allocate the costs of, how do we fund our IT resources? Your book gives you a few of the primary examples. It starts by talking about chargeback, and this is where we charge you back. We We know how much network time your department used, how much so-and-so resource your department used, and we charge you back for that. You pay for what you use. Now, that's really good in that for managers and for everyone, there's an incentive there, a motivation to conserve, to not be frivolous with using the technology, and to share a little more equally, and to maybe not use the resources frivolously because you are going to pay for them and you make sure that you really need them before you use them. And the big deal is you spend huge amounts of time developing systems to keep up with who is using what. So you cannot charge back unless you can keep up with the utilization. Sometimes that burden is just too big, and it's not something we want to do. So again, they have their pros and cons. It is equitable, and so from a motivation viewpoint, that's always strong. But again, there's a real burden for collecting the data. Allocation is another similar, where we allocate based on something, but not necessarily on usage. This way we don't have to keep up with usage. If you've got 20 people in your department and I've got 40 people in my department, then you're going to pay twice as much as I'm going to pay. You know, we're going to pay that percentage based on our revenues, or based on, you know, something besides literal actual usage. So again, there is some equitability here, you know, some equality, some rationale for, you know, the bigger people paying more, but and it doesn't but it, you know, we don't have to keep up with exactly what people are doing, so it's much simpler without having to capture all this data. But it really doesn't capture actual usage, and it could in fact be unequitable if you have a very large department that for some reason really doesn't use. I mean, you know, I look at work, you know, some people use the printers and the copiers just a lot. I almost never use them. When I develop exams, they go through the secretary and she uses the copy center. I don't go into when I'm teaching online classes and I print out your papers, but you know, that's when I use the copiers a lot, or the printers a lot. But it's just the way I do things and the nature of the classes I teach. Others teach classes that require them to do much more handouts and things of that sort, and so they use those facilities more. Some people send a lot of faxes. I don't hardly ever use the fax machine. So again, it depends on what you need. And so if you're asking me to pay for part of the fax machine, I'd say for my business you can get rid of it. I don't need a fax machine. I don't want to pay for a fax machine. I don't use it. Make so-and-so pay for it. Their department's the one that uses the fax machine all the time, for example. So you can create you know, some organizational issues. And that's why I wanted to hit this with you. I wanted you to understand that these are all very real motivational issues that have impact in your as you manage. And then we could use it just as corporate budget, where, you know, it's all seen as overhead, and or activity based, where it's based on on a specific activity. But I just wanted to make sure that you looked at concepts like TCO, total cost of ownership, and funding, you know, IT, and you know, some of these some of these issues that are in Chapter 7, and the idea of the portfolio and what exactly IT does. But I think it's pretty easy reading. Chapter 8 is about governance, and when we look at governance, we've said some things as we talked about the centralization and the decentralization, but we were talking there about the actual physical location and who's using and where are the machines and so forth. But governance is about decision rights and um, and 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 who makes the decisions, who grants the authority, who ensures the performance. It deals with empowerment issues because empowerment is about granting decision rights. It deals with monitoring issues, evaluating the performance. So, and ultimately how we control is very much a function of how we evaluate. And you may think that all IT systems look alike in this regard, and they don't. Some have a very heavily centralized. You know, when we think of security issues, and I can tell you that at USI, things are much more federal, I guess, than they used to be. Much more decentralized. Now, I shouldn't say much more. I should say a little more. The previous CIO, if you will, or IT director, was, of course, from the generation of the mainframe world. And his idea of security and so forth, security is about, if you've got one processor and you can lock it up and put guards around the perimeter, nobody's going to bother your computer. That's pretty secure. You may have oversecured it where people can't get to it to use it. That's always a big deal too. But the point being that if we can control the access, then obviously we're securing our systems. Common sense says it's easier to secure one centralized system than systems all over the organization. And I want you to think today about the challenge of bring your own device, BYOD, that we're seeing so much of today, where people are bringing in smartphones and iPads and they want to use these and they want to be able to get their email and they want to be able to do these things. We want to do online banking on our phones. This is just another layer of another big security nightmare that someone has to solve. Not just security, but the connectivity and all of these issues. But we all certainly are aware of the security issues. So who makes these decisions? And I can tell you that under our previous IT person here at USI, many things that we would ask for in the classroom, the answer was no. No, because someone could get into our system. No. No, we cannot give you a little network for students to play with and build, and because they might somehow be able to get into things they shouldn't. No. That's what we heard over and over and over. We have a new IT director, as our former one retired. And this new director, of course, is a younger person with training in a new generation. And he is decentralizing things and he is changing the structural things. And I'm finding that there's a little more, we're hearing yes. And this person will say, when we look at this person and say, we need a lab space to do this and this, he will immediately, he doesn't say no, he just says, okay, we're going to have to figure this out and that and da-da-da-da-da, but he sets to work on it. So it's a different attitude. And so this is what, we're talking about when we're talking about governance. Is it very centralized? Who really has the authority? Is there just one person? And does this person empower other people? And so that's what this text is about, or this chapter is about. And very much like the centralized and the decentralized in terms of the arrangement, the physical arrangement, that decision power, obviously, and I said this a few minutes ago, obviously this governance, this decision power needs to match the structure. If you've got a highly centralized physical structure, you're probably not going to be empowering scores of people, to work in that centralized environment. You're probably going to have a very centralized. They need to match so that they can work together. On page 239, you see the discussions of the advantages and the disadvantages of decentralized. Obviously, what you want to do is to be aware of this conceptually. What will a decentralized governance do for me? how will it constrain me? And likewise on the centralized. And then you want the arrangement. You want the governance pattern that is going to work for your organization and give you the most benefit. The advantages of centralized would be these global standards. But when you've got one big global standard, then you may have somebody out here on a local level saying, but that doesn't help me. It may help a bunch of other people. It's not helping me. One voice when you're dealing with suppliers. So you're going to get economies of scale and several benefits there. But you're not going to be nearly as responsive for any initiative, strategic or otherwise, because you've got to go through this red tape, if you will, and through this centralized structure. Obviously, you can better recruit your personnel because one person owns all that understanding, or one group, they understand what we need as a whole rather than piecemealing it out there. And likewise, if we look down on decentralized, we see that we get a lot of local attention. We get a lot of inefficiencies associated with that, failures of economy of scale, and redundancies where people are repeating and things of that sort. But that may be necessary for our organization. So I can't tell you, this is best or that's best. What you've got to understand is the advantages and disadvantages of both, and you've got to come up with the arrangement that works for you. And maybe you can recognize as a manager that we've got a governance structure that is not compatible with our physical structure, or that is not compatible with our strategy, for example. These business archetypes, I like this over on page 243 and 244. It's giving you some major categories on 243. Some of our IT decisions are about IT principles, some are about architecture, some are about infrastructure strategy, some are about business application, and some are about investment and prioritization. And then these archetypes, meaning these arrangements of governance. Sometimes we have a business monarchy where it's virtually all done at the CIO level, or CEO level. I mean, it's very business, a group of business executives, and you just don't have a CIO that acts independently. It's just very much held very tightly with the business. An IT monarchy is when it's IT executives pretty well making the decisions. Feudal, you have business unit leaders and key process owners making the decisions. And then, of course, federal and IT duopoly and anarchy. Of course, this is when individual users, and we don't ever suggest this. But at any rate, this gives you an idea of the various possibilities. And then you look over on page 245 and you see that for information security strategy, that's a very business-oriented thing. So it's very common to use the business monarchy, because we're not talking about the security infrastructure here. We're talking about the strategy. So this is a very business-oriented area. And so we don't need a lot of technical discussion here, and you've got to clearly see the full overall big picture for the business. So this would not necessarily be something that you would want an IT monarchy to do, because you would need a lot of business understanding. On the other hand, information security policies, now there's where we have the IT duopoly, where we're going to have IT and business. But see, this is going to have more technical, and so you're going to need more from the IT people here. Some of this may seem to be common sense for you, but again, we oftentimes bring the wrong people to the table. So what this is trying to help you understand is who really should be making these. Some of the decisions in IT are very technical, and as you know, like with the plumber, and as long as the plumber understands what the user needs, then the plumber can be left alone. But some of them are very much more, that's why we don't have a plumber when I have the architect, not caring about where the drain. I just need this architect to help me see this big picture of this place where I'm going to live. So some things we do are much more business oriented. Some are much more technical, and some are a very good combination of both. So these little diagrams here are helping us match all of that together and understand, as a manager, the kinds of things you would need to understand. Now, moving on into Chapter 9 and Chapter 10. Chapter 9 talks about sourcing, and Chapter 10 talks about projects. First, I want to share that a project is temporary, and it's not ongoing. We start a project, and at some point, although we may be a part of that project for 2 years, but at some point we're going to turn it over to the business owner, and we're going to say, I'm out of here. And then from that point on, the business owner will maintain it and so forth. So a project has a definite beginning and a definite ending. And we develop information systems in projects. And one of the early parts of that project is making that business case so that we can get my project chosen, if you will. But I want you to look on page 292 at another triangle called the project triangle, the time, cost, and scope triangle. And I'm backing off and doing the project first because I'm going to talk about outsourcing as a part of information systems development. So I want to mention this project first here, and this time, cost, and scope. The bottom line is, what we often do is we will allow our project scope to creep. We will add on functionalities, and sometimes it's just creeping a little at a time. Oh, can you add this one little screen? Can you add this one little function? Yeah, I'll just add it. And we just let it creep. The scope creeps, but we don't ever change the budget or the calendar. And then we wonder why we're behind and why we're over budget. We cannot allow our projects to creep. Now, we can allow our projects to change. We should have a change management group so that if I come to you and say something has changed since we last met, and I'm going to need a new functionality because we've got a new something coming on, and we may talk about it, and this change board sees, okay, I get it, we've got to do this, but it's going to add 2 weeks and $10,000 to the, and so in other words, you keep the triangle balanced. You don't just change the scope without changing the calendar and changing budget, because you will get all out of whack. The only way you're going to have quality in a project, which means it's going to come in doing what it needs to do, it's going to come in on time and on budget, is if you keep this triangle. And I don't care what anybody tells you, we can talk all day long about the complexities of project management. It comes right down to this. If your scope moves, you better recognize that you just moved your budget and you just moved your calendar. And if you don't have enough budget or you don't have enough calendar, then don't move the scope. It's that simple. Sometimes one of these, and they all constrain one another, but sometimes you're in a situation where you have X amount of money, period. My husband's doing some work on a farm here, putting in some new fencing and some feeders, and kind of upgrading a farm that we have and moving toward retirement when we probably will run more cattle and than we're running now. And bottom line is, he's got a budget and he's got some money in his farm account, and he's talking to these people and he's saying, this is what I want done and this is how much money I've got. Will you do that? And we're getting bids from people. But the bottom line is, he's made it clear to him that the money is it. So, don't come back to me later and say, I didn't figure this in or I didn't realize that. The money is the constraining factor. This is the absolute penny that I've got. No more. And so many times that's the way it is in an organization. So even though we would like to let the scope change, and oftentimes if we allow the time, we end up spending more money because we got off schedule. The time, the longer we work on it, the more salary, the more people, the more resources. So there goes our budget up. And these people may come back and say, well, I thought I could do this in 2 weeks, but I see it's going to be another week, and I'm going to have to pay my help an extra week, and I'm just not going to be able to do it for that money. I'm sorry. I told you you could not go over that dollar amount. And so you see what happens then, we get into a bind. We get projects that don't get completed or don't get completed properly, or everything kind of goes to hell in a handbasket. So pay special attention and spend time thinking about that time, cost, and scope, resulting in the quality project triangle. Project management is a very, it's a huge thing. There are people who make loads of money being project managers. Project managers are very much in demand. And this chapter kind of lets you know that you know exactly what we mean by project management, who's kind of in charge of overseeing. I have an article that I sometimes put out, and I may put it out, by the way, for your final exam. But it's the Denver Airport example, and it's a huge project, and there were just a lot of project management and leadership issues that led to a lot of failures. So a lot of times people do not understand that orchestra leader that's up here managing and pulling it all together, it's very, very complex. You're dealing with the vendors, you're dealing with the users, you're dealing with the IT people, you're dealing with the business people, you're dealing with, you know, it's very complex, and it has, you know, a lot of issues, but it's very, you know, it's very, very critical. We have an entire, go to the Project Management Institute, PMI, and they've got a big website. This is an organization that is devoted explicitly to project management. We have journals out there that are all about project management. Later in this chapter, it talks to you about the systems development life cycle, and basically that's, I'm going to say this and then circle back into outsourcing. So let's say that we've ultimately gotten approval for a particular system. We're ready to, it's been approved, and we're ready to start. And we need some type of a methodology. If we just start rambling down the road, how do I know if I'm on schedule or off or whatever? The systems development life cycle is a very thorough, but it's very sequential and rigid. It is a methodology and an approach to developing systems. We started using this back when we first started doing, back in the day, we were doing a lot of highly structured transactional type systems that were proprietary in nature, and this was what a lot of our development was, and we were pretty much developing them all in-house. And we were developing, it was more like an art, and as we began to bring in some engineering principles to try to make it more of a science, so that we would do a better job with our development, and we called it structured development, if you will. And so the systems development life cycle is an older methodology that's been around for a long time, and it worked extremely well in that environment. It still works extremely well in that type of environment. But here's the deal. You start off with, and different people will give you a different number of phases because they will make some of them more, they'll subdivide more than others. But in essence, you're going to start off with your planning phase, and you're going to plan your project team and start with your budget and get your people together, and you're going to do your diagrams, your network diagrams showing how long you expect it to take, and you're going to do your initial feasibility studies. So you just start out planning the actual project, and then once you realize that it is indeed feasible, now that you've put the pen to the paper a little more carefully, then you move into the analysis phase, and this is where we are looking to develop the business requirements. What does the system need to do? And we may do interviews, we may do interviews and questionnaires, and look at reports and all other kinds of organizational documents, and just spend lots of time observing and spend much time with the users and trying to understand what the system is like now, but basically what, not how, what does the system need to do? And then once the output of that planning phase, waterfall, it's like a waterfall. It flows down into the analysis phase, and then the output of that analysis phase trickles down into the next phase, which is the design phase. That's why it's often been called the waterfall. And so then once we have this what and this business requirements determined, from this point on now, it's like a recipe. We're going to bake the cake. The design phase is where we begin to work on how this is going to happen, and we begin to actually come up with the physical translation of this what into the how. And then of course your implementation phase is where you actually, you write the code, you test it, you put it into the process, into working. And your book talks about parallel and cutover, and I forget exactly where that is, but I saw that. But if you, the bottom line is, when we cut over to the new machinery, to the new system, we can either cut over directly or we can cut over indirectly. And what we can do, a parallel conversion, is where we run them both together for a period of time to make sure that all the kinks are out. This is by far the safest, but it is way costly because we can't share any resources. We have to have two complete systems running. If it's very critical, then of course we would choose that. It would be worth the money. A direct cutover, on the other hand, is where we turn off one and turn on the other. So we could share common resources because the two will never run together. This is by far the cheapest, the most efficient, but it's also very, very iffy. You have to make sure it's going to run when you turn that other switch off. And then we have those phased in between. Sometimes we do it one department at a time, or sometimes we do this part of the system and then this part of the system. So this is what your book's talking about in terms of how we actually bring the system into being. But back to the systems development life cycle, it's very thorough, it's very time consuming and very resource intensive, but it ends up being very well thought. But notice that it's very sequential. The output of one phase becomes the input of the next phase. Notice that I never go back and forth. I never question up here in the design phase anything I learned in the what phase. What if things have changed? Well, I'm going to just keep on going, and I'm never going to know it till I get to the end and there's a problem. So what I hope you're seeing is that this systems development life cycle in its most rigid form is a very good methodology, but it only works. Notice that it's that second phase where I'm going to determine business requirements. What if I don't really understand the business requirements? What if these have to evolve? I remember the first time I had a website, a man came into my office and said, I'm creating websites for each of the faculty. Do you want one? I'm sure. Okay, what do you want your website to be like? And he's sitting there poised with his pen and paper waiting for me, the user, to tell him what I want. I said, well, I don't know. What should I want it to look like? Well, what are you going to do with it? Well, I don't know. What do you do with the website? And I didn't understand at that point well enough to. So in today's world, things are so dynamic that we don't always know right up front. I can't tell you right up front. I can't develop the recipe and then let you bake the cake. Sometimes the recipe has to come out while we're baking the cake. That's the more agile development, the more evolutionary reports, where we go back and forth, like prototyping and things, and this is what Romero did with me. He got me to say a thing or two about color or whatever, and then he left and he sent me a mock-up of the site. And he said, what do you think of this? Well, once I looked at it, I said, well, isn't that too small? I think I want that font bigger. And what are those semicolons? And what is this thing up here in the corner? And how are my students going to be able to know my phone number? Because you didn't put it on here. And I think I want my picture. And so he went back and he changes it and then he sends it back again. And then I look at it again and I think, yeah, that's better. But this and but that. And we go back and forth. It evolves. That evolutionary, agile, a much different to the very rigid SDLC. So I want you to see that as a continuum and understand that if you cannot know your business requirements up front, then the SDLC is not going to work for you in its most strict form. Also, maybe you can know them right up front, but there's a possibility that they're going to change before you get to the end. Then that's not a very good approach for that either, because it has no mechanism built in for you to check on making changes. Now, let's back up to outsourcing, and let me say that when we develop systems, we have a couple of options. We can make or we can buy. Most people today are not, quote, making their own systems. They may be writing code to tie applications together. But there is such a software market out there today that most of the organizations are not actually making their own systems as they did back in the 50s and 60s when they had to write their own transaction systems for their own proprietary systems, because we have general purpose systems now that a payroll system that can be used across many industries, but even within industries for all of the intricacies and the idiosyncrasies of your particular industry. We have flower shop software, we have auto body shop software, we have medical, dental office software, and the list just goes on and on. So why? I mean, it's exorbitantly expensive, and you have to have a huge staff to write, and the testing is ridiculously lengthy. So why would we reinvent those wheels? Well, sometimes we would because we can't find anything that meets our needs, or because we are protecting some strategic process. It is the way I do that thing that gives me the edge. So I'm going to write my software. I'm not going to do it just like everybody else. I'm going to do it distinctly different. So if we're protecting some unique or distinctive competence, we might write our own. But most of the time, that's not what we're doing in today's environment. Now, one other option that we have is outsourcing. And outsourcing is very different today to what it was when we started with outsourcing. But it's appropriate for me to say when I go buy Microsoft Office off the shelf, I'm outsourcing the development of my software to Bill Gates and Company. So we understand that one form of outsourcing is outsourcing the software development. But what we're talking about here in this chapter is outsourcing functionality. We might say, I'm not going to send out my own bills. I'm going to pay someone to send out our invoices. I'm going to pay someone to do my payroll. And in some instances, I'm not going to have an IT department. I'm going to pay someone to do all of my IT work. So again, it's a continuum. And you may have one person doing all of it, or you may have multiple vendors. It's much more complex than I'm going to make it seem in this very brief set of comments. But again, you've read the chapter, and what I want to do is just to make sure that I simplify it kind of conceptually, and you understand what we're talking about and why we might do this. A lot of reasons why we might do it, but number one, it takes a fixed cost and makes it variable. Instead of keeping this huge payroll department, and I have to have all of them here for the peak times or whatever, I can pay you to do my payroll, and instead of keeping all this equipment, all this people, and all these salaries and benefits, I just pay you for X number of dollars for each payroll, each paycheck you do, or each transaction or whatever. And the same thing on invoices and things of that sort. I'm sorry, I've got something in my eye and it's kind of hurting. So it allows us to offload a very large fixed expense and now only pay variable. It can improve quality. These people do nothing but payroll. Why not let the experts do it? They're obviously going to be able to do it cheaper than you, probably, because they're going to get economies of scale because they do it for so many people. So these are some of the arguments to save money, to let the experts do it. And when I let the experts do it, that's also meaning that it's freeing me up to devote myself to my core activities. So I can concentrate on my core and not necessarily on the IT issues. Sometimes we do it to raise some money up front. And this is something that a lot of people don't really understand as well. But the bottom line is, if I own a railroad and I am running my own coal back and forth across that railroad. If I decide I don't want to do my own coal, let me sell you the railroad for millions of dollars. Oh my, but now I'm going to have to turn around and pay you? How stupid was that? Surely I could run my own railroad cheaper than I can pay you now to run my coal up and down it. Well, maybe I needed a few $1 million of capital or money, and now you've given me that, and now I'm going to pay you, over time. I'll pay you for what you're going to be doing, but I needed the money, whatever my strategy or my goals here are. I gave you this example because I wanted you to see that when we outsource our departments or our functions, oftentimes we are selling equipment and resources to that particular organization. So the money stream is lumpy. You get a lot of money right up front because you just get paid for your railroad. They don't get their money until they've trucked enough or run enough coal up and down the railroad to collect the money from you. So you get an influx of money right up front, but they get theirs more slowly. So when the payment stream is lumpy, it causes you to have different priorities. One of the big issues with outsourcing is the agreement. And the agreements, we're getting better at it now because we've been at it for years, but they're very complex. And outsourcing arrangements don't always work. And if it's not working and it's hurting your organization, you would like to bring it back home very quickly. The quicker you bring it back home, the better able you'll be able to do it. And also, the quicker you'll be able to stop this damage that's happening. So you would prefer to have the contract be a little shorter so that if you need to jump ship, you can. But they're going to need a contract that's longer that allows them enough time to make enough money to recoup their investment. So these are just some examples of things to consider. And you can get online and you can find example after example after example of outsourcing. And some of those are horror stories. Some of them are very, very successful. And all of them are very dependent on a relationship. You cannot be outsourcing with somebody and you're using them or they're using you. It has to be a mutually useful, a true relationship. What is the downside of outsourcing? Well, you're losing control. If your bills don't get sent out on time, your cash flow is going to suffer. If your payroll is botched, ooh-wee. Whatever you're paying these people to do, if you're giving up control of that, and that's very, very scary. So when you read this chapter on outsourcing, just pay special attention to all of the advantages. Why wouldn't I do it? But also understand, the disadvantages along with the advantages. And quite frankly, virtually all organizations do some form of outsourcing, and some do more than others. It's very common. Much more sophisticated now than it used to be. We really understand more and more now about writing the contracts and who upgrades the software and who has to pay for this and how often. No, I don't. There's nothing in the contract that says we have to get new software. Well, their software is so outdated that it's causing us real problems, and they're keeping up with our inventory, but they don't have software that'll interface with a lot of our vendors. Well, you're going to have to do that. Well, nowhere in the contract does it say that. You see all kinds of things. We have to really cross those T's and dot those I's and make sure that we're very explicit. So it's a very complex arrangement. I just want you to understand that. But it's rather conceptually simple as to why we would let someone else do things for us. We outsource things all the time. We pay people to do things for us. We outsource our lawn mowing because we don't want to spend the money. My brother has said that because he lives in a subdivision and there's always little high school boys, he has a small yard, there's always a little high school boy that would love to have 20 bucks, to mow his lawn. And he said, when I consider what it costs me to buy a lawnmower and the gas to run it and my time, there is no way, he said, that I'm going out and buying, and I'd have to have a shed to keep it in. I'm not doing it. He says it's absolutely ludicrous for me to do it. And so I just pay, $20 and whatever. And so, we understand conceptually about paying people to do things. And so it's important for us to understand the concept of outsourcing and to realize that the concept is not some crazy half-baked thing. It's very real. It's very common, but it is very complex. But it's not something the IT people don't just sit in a room and say, what, instead of writing this payroll system, why don't we just outsource the payroll? No, that's a business decision. It's not an IT decision. Now, it's a decision that goes both ways, don't get me wrong. But maybe the IT people are saying, we don't have the staff to do such and so as things come up, and we could outsource that, or we could, and then it's a mutual decision. But it's not just something that IT says, I think I'll offload this. Not to say they can't subcontract, and they do. We do outsource a lot of programming. A lot of shops do not do a lot of code writing, and they will offload their code writing to independent contractors, for example. So it's a real continuum when we're talking about outsourcing, whether we're outsourcing just very small things or we're outsourcing a very large portion of what we do. I know this has been kind of lengthy, but we've covered a lot of ground, and I hope that I have at least helped you conceptually understand some things in there that might have been a little confusing for you. I understand that some of you are understanding this very well. Some of you work in IT, but believe it or not, there are others of you that are calling me regularly, asking me for clarification, and we're having long conversations on the phone as we're trying to, to get to understand this stuff. So I'm trying to get kind of somewhere right in the middle, and those of you that need more, please call me. Please feel free to do that. Hope you have a good day and a good week.